So now, what is the amount of time this algorithm takes?
Theta of n, sir.
Theta of n. Okay, without actually even knowing about what this algorithm is doing, easily we can calculate now what is the amount of time it takes, provided n is r minus p plus 1. What is the time for step 1, step 2, step 10, 11? What times for all these 4 steps? Theta of 1 or 1 step. What is time for step 3? Time for step 3. What is time for step 3? Okay, if step 3, if you are not able to clearly say 4 and 5, 4 and 5.
Order of n.
Order of n.
It is actually n by 2 times, n by 2 times, or exactly speaking, n1 times. So we can say that it is, because our answer should be in terms of n, no, we can say that it is theta of n. Is that correct? What about steps 6 and 7? 6 and 7, what is the time? Similar to that, it is also theta of n. 8 and 9? 1, 1, 1, 1. What is actual comparison we consider as basic operation? This is our comparison, no? Comparing elements of one array with the other. Comparison. Now what is time for step 12? How many times it is repeated? For k p2 r 1 time, what is this value? R minus p plus 1, which is same as n. So this step is performed how many times? Theta of n times. Is that correct? Is that correct? Step 13, theta of n. 14 and 15. 14 and 15, at most n. At most n. This is also at most n. So overall, what is the time? Easily we can say that it is how much? Theta of n. Is that okay? So what is that they are doing here? What is that they are doing here? What is that they are doing here? So the two subarrays A, P2, Q and Q plus 1, 2 R. These are two subarrays, no? Subarray 1, subarray 2. They are copying that into, to say, two new arrays. This is left array. This is right array. Left array and right array. Then what is that they are doing? They are comparing one first element here with the first element here and copying that result into as a first element here. Then going to where next element, wherever minimum has come from, this means they are going to next element and comparing that and copying that value here. Keep doing like this. This is the procedure they are doing now. Now you tell me, what is the amount of addition? What is the space complexity of this algorithm? What is space complexity of we are talking about merge sort. Where is that? What is the total space it takes? What is the amount of space here? It is constant up to this, but merge procedure, how much space? Merge procedure, how much space?
2n plus a.
Asymptotically?
Order of n, sir.
Order of n. Correct, no? What is total? Actually, it is 2n plus some constant we can say. 2n plus some constant, 2n plus some, why additionally n? This L array n by 2, R array roughly n by 2, overall it is n. Is that correct? 2n plus some constant, that is theta of n. What is the additional space? Additional, whenever I say additional space means space other than input. Additional space. What is the additional space this algorithm takes?
N.
Merge sort algorithm. It is whatever merge procedure is given. Here it takes these two are new arrays. No. For this, what is the amount of space? It actually depends on input size n. So, and it is theta of n. Additional space is theta of n. Now you tell me this implementation, whatever merge sort I showed here, is it in place? Is it in place or not? Is it in place sorting algorithm or not? With the implementation shown here, is it in place?
No, sir.
Not in place.
Not in
No,
place.
sir.
But in place versions of merge sort also possible. That's why here no, there is a both variants are there. Okay, at least in other cases we were able to say clearly they are in place. But here this way, this implementation it is not in place, but in place versions also available for merge sort without additional memory. Also they are available in the literature. Implement both implementations. Is that okay? So that's why I am not saying whether it is in place or not in place merge sort, but this variant I can say that I can say that it is not in place. This implementation it is not in place. Not in place. Is that okay? So any doubts related to merge sort?
No, sir.
Because there are many variants of merge sort also. Okay, no, with some, okay, no, this is two-way merge sort. Like that, similarly, we have four-way merge sort, two-way merge sort. We have four-way merge sort. That means we divide that array into 4 subarrays. Then do the same thing. Then what is the reconciliation we get? If it is four-way merge sort, what is the reconciliation we get? What is size of each one? N by 4, n by 4, n by 4, n by 4. Then what is reconciliation? 4 times T of n by 4. Again merging. Merging means what is that we need to do? This is sorted subarray, this is sorted subarray, this is sorted subarray, this is sorted subarray. Compare first elements in each sorted subarray. This one, this one, this one, this one. This may be 8, this may be 2, this may be 10, this may be 4. Now 8, 2, 10, 4 we need to compare, and we need to say whichever is minimum, that we need to move it into resultant array. So 2 is minimum, it goes. Next we'll compare this element here. Now how many comparisons are required to find the minimum of 4 elements? How many comparisons are required to find the minimum of 4 elements? How many comparisons are required to find the minimum of 4 elements? How many comparisons are required to find the minimum of 4 elements? Already we discussed no minimum algorithm in selection sort, same procedure, minimum only we discussed. No? How many comparisons are required to find the minimum of 4 elements? First element we can say it as minimum. 8 is
Yes,
minimum.
three comparisons.
Three comparisons only. That means number of comparisons required no to find minimum. Is it constant or not? Does it depend on n value?
Yes, sir.
Right.
10 minus 1.
Here also it is. Here also it is. We can say that at most n. For each to find one resultant element in the final array, we need 3 comparisons. Like that, n minus 1 into 3 we can say. Is that correct? N minus 1 into 3. Not more than that. So that is also again theta of n. Even if I go for 4-way merge sort, also again what is running time? T of n is which case of master theorem? Second case. There is no change, again theta of n log n. Theta of n log n. Okay. because there are other variants also that we are not going to discuss. External merge sort. Okay, no, external merge sort of those things. Next one is another sorting algorithm, that is Quicksort. Do you remember how does Quicksort work? How does it work? How does it work?
Yes, sir.
Okay. So now I'll just give outline of this. I'm not going into.
Shall I say, sir?
Please, you can say, madam, no problem. How does it work, madam?
Yeah. When we select one element as the pivot element,
Hmm.
and after the first round,
Hmm.
first iteration, all the elements which are less than pivot will come to the left side of pivot, and all the elements which are greater than pivot will come to the right side of the pivot.
Okay.
And we'll apply the quicksort recursively on the left half and right half again.
Thank you very much, madam. Okay. Same thing, no, whatever madam said, is it correct or not? For example, if it is input, what is that we do here? It is input array. So what is that we do? So in the given array, one element we consider it as most important element. One element we consider as most important element. With respect to that element, we divide the array into two subarrays. Is that okay? We divide the array into two subarrays. So the most important element, if I am choosing here, is say 18. 18 is the most important element I am choosing. So now what happens here? In the final sorted order, this is say output. In the output, what is position of 18? What is position of 18? What is the sorted order here? 10, 12, 14, 18, 18, 20, 24. This is the sorted order now. Positions are 1, 2, 3, 4, 5, 6. What is the actual position of 18? In the final sorted order, what is actual position of 18?
Fourth position, sir.
Fourth position. So here what we do is we consider one element as most important element. We compare that element, all other elements in the array with that element. All other elements in the array with that element. Okay. Then we ensure that this element goes to its own position in the final sorted order. Goes to its own position in the final sorted order. What is its own position in the final sorted order? What is its own position in the final sorted order? What is its own position? That is position 4. That means first what we do is, now whatever input array is given, we ensure that whatever important element we have selected, that is 18 goes to its own position in the final sorted order, so that after that we need not disturb that 18. Then all the elements to the left side of 18. Okay, now if I assume that all elements are distinct, all the elements to the left side of 18, they are, this is left side, they are smaller than 18. All the elements to the right side, they are greater than 18. So what happens is, if we are given array of some elements, we consider one element as most important element, we compare all other elements in the array with that element, and ensure that after this comparisons, that element goes to its own position in the final sorted order, and all the elements to the left of that element, they are smaller than that element. All the elements to the right are greater than that element. Then what is that we need to do? Then again, all the elements to the left of 18, that we consider as one new array given to us. All the elements to the right of 18, this is 18, which is in position 4. All the elements to the right, this we consider it as new array. Again, recursively, we sort this. Recursively sort L and R. Is that correct? Is that correct? Can you recall whatever you learned no? In Quicksort? So what happens in Quicksort? Only one important point. What happens in Quicksort? We consider one element as most important element. With all other elements in that array, we compare with that element and ensure that the selected element goes to its own position in the final sorted order. And the elements to the left of that selected element are smaller than that element, to the right are greater than that element. So that we will get two new arrays, subarrays. One is to the left of the selected element, the other one is to the right of the selected element. And these two subarrays, again, recursively, we sort it. Is that correct? Is that clear? Is that clear? Is that clear? Or is there any doubt in this?
No, sir.
No. Okay. Now, for example, now we generalize this. For example, we are given an array whose starting index is P, array A, whose starting index is P, whose ending index is R, as usual. Here again, assume that N is R minus P plus 1. Okay. Okay. We are given some N elements where N is R minus P plus 1. Here we consider one element as most important element, and after that, if for example, if that element has gone to say position Q, whichever element we consider as most important element, that element has gone to position Q. Then what does it mean? Now what is left part of the array now? What is left part? What is left part of the array? And what is the right part of the array in this case? Left part of the array is
P2 Q minus 1.
P2 Q minus 1. What is the right part? Q plus 1 to R. Is that okay? Now we recursively sort left and right subarrays. Left and right subarrays. Okay. Is that clear? Is that clear? But in order to, we consider one element as most important element, and with respect to all other elements, we compare with that element. No. And after that, the array is divided into subarrays. So in order to do this, there are that means what is happening here after sending that element to its own position, array is divided. That we call it as partitioned. Array is partitioned. So in order to partition the array, we whatever procedure we use, no, that we call it as partition algorithm. So what does this partition algorithm of Quicksort do? What does it do? It considers one element as most important element. It sends that element to its own position in the final sorted order, and it automatically, based on that, array is divided into two parts, one with elements smaller than that, one with elements greater than that. Is that clear? Is that clear? Is that clear? Next important question is how to find this position Q. That means how to send this to its own position. For that, whatever procedure we use, that we call it as partition procedure. There are different partition procedures in case of Quicksort. Okay, no, Fourier partition is one. that is, it was actually this quicksort algorithm, no, it was invented by Tony Hoare in Tony Hoare. I think that time he was only 23 years old, if I remember correctly. He was a visiting student at Moscow State University, Russia. Okay, they were actually working on some project which translates from one language to another language. In the process, they came up with an algorithm. Okay, that whoever invented this quicksort algorithm, no, that time he was how many years old? Only 23, if I remember correctly. Okay, that's fine. So that is called Hoare partitioning. There is another partitioning algorithm also that is Lumotov partitioning. Like this, there are different partitioning algorithms. But all, what do they do? Whichever element they consider as most important element or pivot element, they send it to its own position in the final sorted order. Left to small, right more than that. That's all. That's all. Now tell me. So here, if there are, our array is A, P2R, P2R, P2R. How do I know that whether there are at least two elements or not? At least two elements or not? If P is less than R, what does it mean? What does it mean?
2 elements, sir.
At least two elements. At least two elements. That is the meaning, no? If there is only one element, that itself is sorted order, we need not worry. We need not worry. So in this case, what we do is this, we apply partitioning algorithm. I have used capital letters here. Okay, partitioning algorithm, which takes array name TR, and what does it return? What does it give? After partitioning is over, what does it give? What does
Pivot
it give?
element.
Pivot elements, the actual position in the final sorted array. Pivot element is okay. No, so I am going to explain a method where it considers last element as pivot element. Last element as pivot element. So what is our pivot element here? Pivot is A of R. Last element as pivot element. Is that okay? Last element as pivot element. Now this is P, this is R. For example, say pivot has gone to this position. Pivot has gone to this position. That means what is value here? What is value here? This is pivot value. This is pivot. What is its position? Its position is Q. It's Q. Its position. So this side it is Q minus 1. This is Q plus 1. What is our left subarray now? What is our left subarray? Left subarray is P2, Q minus 1 left subarray. What is right subarray? Q plus 1 to R. What are the elements here? They are smaller than pivot. This side they are greater than pivot. Is that okay? Is that okay? Now, after that, what is that we need to do? After that, what is that we need to do? Again, P2 Q minus 1, do we need to sort or not? And similarly, Q plus 1 to R, do we need to sort or not? So for that, again, same quicksort algorithm we use. Again, here we use quicksort algorithm to sort this subarray. Again, we use same quicksort algorithm to sort this subarray. That means it is recursive calls. Recursive calls. Is that correct? So now, unlike, okay, I'll come to that after. So now whatever procedure I discussed, no, this is if P less than R means what? Greater than or equal to two elements. If there are greater than or equal to two elements, what is that we are using? First, we call partition procedure. Partition procedure. It returns what is this Q? What is Q here? What is Q here? What is Q here? Position of pivot in the final sorted order. position or that, no, the index we can say. Index of pivot element in the final sorted order. Is that okay? Index of pivot element in the final sorted. Now what is this? This is left subarray. Is it clear? Left subarray. This is right subarray. Now you tell me, in this, what is divide step, what is combine step, what is conquer step? Which step is divide step in this algorithm?
Second step is divide step, sir.
Which one?
Second step, sir.
It is divide step. Thank you. Okay. Which step is conquer step?
Third and fourth are conquer steps, sir.
These two are conquer steps. Is there any combine step here? Combine. No, there is no work, combining work at all in this algorithm. Is that okay? Unlike merge sort, where in merge sort combine step is most important step. But in quicksort, is there any work in combine step? No work at all. Why? Every time partition algorithm is called, one element goes to its own position in the final sorted order or not? Every time partition algorithm is called, one element goes to its own position in the final sorted order or not? Is that correct? After that, array divided. Then do I need to disturb that element which is already in final sorted order? No. Simply invoke partition and send one element to its own position in the final sorted order. Like that, one time if you call partitioning algorithm, how many elements will go to its own position in the final sorted order? If you call partitioning algorithm once, partition procedure once, how many elements go to their own position in the final sorted order?
One element.
One element.
At least one. Sometimes it can be even more than one. Partitioning algorithm is called means sends at least one element to its own position in the final sorted order. Is that okay? Now you tell me, if this is the case, how many times at max we need to call partitioning algorithm if there are n elements? How many times we need to call partitioning algorithm if there are n elements?
Times, sir.
How many times we need to call partitioning algorithm if there are n elements?
Times in
N
maximum.
times.
N times.
Maximum. Okay. No. So number of calls to this is not more than n minus 1. Why did I say n minus 1 here? If n minus 1 elements are in their own positions, remaining one element will be in its own position or not? See, there are 4 elements. Our elements are 10, 30, 40, 20. 10 is in its own position, 40 is in its own position, 30 is in its own position. Whether 20 will be in its own position or not? Whether 20 will be in its own position or not? Whether 20 will be in its own position or not? Automatically, no. Remaining element is 20. We are only comparing one element with and we are updating elements. So here automatically 20 will be there. So that's why I need not call n times. N minus 1 times it is enough, no? N minus 1 times it is enough. That means here only one element is there. Do I need to call again partitioning algorithm if there is only one element? No. Is that clear? Number of calls, why it is not more than n minus 1? Is that clear?
Sir. Clear, sir.
Okay. So if I call partitioning algorithm once, how many comparisons does it make? If you call partitioning algorithm once, how many comparisons does it make?
N.
N minus 1, can you say, sir?
Yes, we can say minus
That
1.
element, pivot element, we need not compare it again, no, with the same thing.
Yes, sir.
So one invocation of partitioning algorithm, it compares comparisons performed here is comparisons is not less than. Exactly we can say, no? Exactly we can say if there are n elements, how many comparisons is n minus 1. It has to be compared with all other elements. No, there are n minus 1 other elements. Is that okay? In case of, okay, now we just go back to this. Now we try to calculate what is the time this algorithm takes. At least we know that partitioning algorithm n minus 1 comparisons are performed. That means what is its running, what is the time it takes? Can we say that it is theta of n? Is that correct? Can we say that the amount of time, if there are n elements, amount of time partition procedure takes is theta of n? Is that correct? Is there any doubt in that? There are n elements. One element we can say it as important element called pivot element. Remaining n minus 1 elements we compare with pivot. That means n minus 1 comparisons. Is that correct or not? It's order of that n minus 1 can be written as theta of n. Is there any doubt in that partitioning algorithm, partition procedure running time?
No doubt, sir.
Now left to subarray, this is right subarray. What is the time for left subarray? What is time for left subarray? If there are n elements, this entire algorithm we can say it as, what is the time for this entire algorithm? If there are n elements, this T of n. What is n here? Number of elements, no? Number of elements. If there are n elements, total time is T of n. Now you tell me what is the time for this left subarray? In order to sort this left subarray, similarly right subarray.
There are different possibilities. We need to explore it one by one.
Less than T of n we can say, but exactly we can't say, sir.
Exactly we cannot say, but because for that we don't know exactly how many elements are there on the left side and how many elements are there on the right side. So, but possibilities, can we say left side 0 means what can we say about number of elements on the right side? Left
N
side
minus
there
1.
are 0 elements. N minus 1. Left plus right it will be n minus 1. No, left side 1 means, is that correct? Left side 2 means, right side n minus 3. Left to 3 means n minus 4, and so on. Left to I means how many elements on the right? How many elements on the right? How many elements on the right? How many elements on the right?
n minus I minus 1.
N minus 1 minus I. We can generalize, no. N minus 1 minus I. And so on. Last, left can have n minus 1 elements. In that case, what is the number of elements on right? 0. 0. Is that okay? But we don't know exactly. If left is 0 elements, what is the time it takes? What is the time it takes? T of 0. If right is n minus 1, then it is, this is one combination. One side 0, one side n minus 1. What is the other combination? One side 1, one side 2. Other combination, one side 2, other side Okay, this is n minus 2, no? Other side, n minus 3. One side 3, other side n minus 4. And so on, one side I, other side, one side n minus 1, other side 0. Anything can happen, no? Anything can happen. If first case occurs, if this occurs, then what is the total time this algorithm takes? Left to 0, right is n minus 1. What is the time it takes? It is t of 0. It is t of n minus 1. What is our recurrence relation? What is recurrence relation? Recurrence for running time of quicksort. Recurrence for running time of quicksort. See, first step we know that it is constant. Second step we know that it is theta of n or n minus 1. Third step we know that t of 0. Fourth step we know that t of n minus 1. In this case, what is recurrence relation? T of n can be written as constant plus n minus 1 plus t of 0 plus t of n minus 1. Is that correct? Provided we know that left side 0 elements are there, right side n minus 1 elements are there. Is that correct? Is that correct? Is that correct? Is there any doubt in this? Is there any doubt?
Sir.
But do we really know that there are 0 elements one side and n minus 1 elements other side? We don't know. We don't know. Then how to find the time? What is the time this algorithm takes? What is time this algorithm takes? How to find what is the time this takes? So now we know that left side and the right side, it can be t of 0 plus t of n minus 1. This is one combination. T of 1 plus t of n minus 2. This is another combination. T of 2 plus t of n minus 3. This is another combination. Plus and so on. T of I plus t of n minus 1 minus I. This is another combination. Or in the worst case, last t of 0. These are the possibilities, no? We may be in case 1. This is second possibility. This is third possibility. This is last nth possibility, no? Case number. We may be in case 1, case 2, or n, case n. Is that correct? Is that correct? Is that correct or not? Now you tell me what is the recurrence relation for running time of this? What is recurrence relation for running time of this? What is, or there may be some case where one side n by 2 elements, if there are n by 2 elements on one side, what is the number of elements on the other side? What is number of elements on the other side? N by 2 minus 1. Is that correct? Is that correct? For example, this case, what will be our final recurrence relation? We are counting only comparisons. Then we can write it as n minus 1 is comparisons plus this case, case 1. Case 1 I am talking about. It will be t of 0 plus t of n minus 1. That means what is t of n value? What is t of n value in this case? What is t of n value? Can we say that the t of n is theta of n square? This type of recurrence relations we have already solved, no? Substitution method. Do you remember? Same recurrence relation, in fact, we solved, no? What is t of 0? What is t of 0? 0. No work at all. T of n minus. So it is finally t of n is t of n minus 1 plus n minus 1. Is that correct? This recurrence relation solution is this. Similarly, if I look for this, what is recurrence relation? T of n is n minus 1 plus T of n by 2 plus T of n by 2 minus 1. This can be written as less than or equal to 2 times T of n by 2 plus n minus 1. Is that correct? Is that correct? T of n by 2 minus 1, I can say it as T of n by 2. Hence, I am able to write it as 2 times T of n by 2 plus n minus 1. Is that okay?
Yes, sir.
Okay. So, according to this, what is this value? T of n can be by case 2 of
N log n.
case 2 of master theorem. Case 2 we can apply master theorem. What is the answer here?
Big O of n log n.
Big O of n log n. By case 2 of master theorem, it is big O of n log n. But here it is theta of n squared. That means what? All cases are the same or not? All cases are the same or not? Different cases are going to give different running times or not? Different cases are going to give different running times or not? Different cases are they going to, that means different cases are they going to give different running times or not? We don't know which case among these n cases occur, but for different cases we have different running time, no? Different cases we have different running time or not? Hence, what does it mean? What does it mean? It not only depends on the number of times comparison performed, it not only depends on n, but also actual values in the input. But also actual values in the input. That's why we will have best case, worst case, and average case like this. Okay, no? Best case, worst case, and average case. So when does best case occur? That is, T of n is, see, if you go to actual algorithm, the second step, what is the amount of work we are doing, irrespective of what are the elements there, n minus 1 comparisons, no? Third and fourth only changes, no? Third and fourth only changes. So that's why T of n can be written as n minus 1 plus, I am looking for best case. Best means what? First, I will calculate answer for this part. Similarly, I'll calculate answer for this case, answer for this case, answer for this case, this case, this case. All n cases, I will calculate answer. Among all this, wherever I will get minimum value for T of n, that I call it as my best case. That means what? That means what? That means what? T of n minus 1 plus minimum, I am looking for minimum of I, what are the values I take? I can take 0 to n minus 1. 0 less than or equal to I less than or equal to n minus 1. Can we say something like this? T of I plus T of n minus 1 minus I. Is that correct? This, can we call it as best case running time? Can we call it as best case running time? Now, is it clear why I have written minimum of I? Best case means where the total number of comparisons is less. We don't know, n possibilities are there, which case is less we don't know. That's why all cases we find answer. Wherever it is coming minimum, that we say that is our best case. Is that correct? Is that correct? Is this clear why I have written this? Similarly, in the worst case, can you tell me what is the reconciliation in case of worst case? N minus 1, there is no change. Instead of minimum, what is that we get? Maximum. Is this correct? Is this clear? This is second case. Now, what is that we need to find? 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 For which value of I, this is minimum. What is the I value for which we get this as minimum? Minimum occurs when I equal to n by 2. It has been shown that, okay, I am not going into the proof of this. Okay. Similarly, it has been shown that maximum occurs. These are also simple proofs, but I am not doing that. Maximum occurs if I equal to 0 or I equal to n minus 1. I equal to 0 or I equal to n minus 1. That means now you tell me, if it is best case, what is the reconciliation? I know that I equal to n by 2 minimum occurs. Now you tell me what is the reconciliation? What is reconciliation in case of best case? Instead of without minimum, can you tell me? T of n equals to T of n equals to T of n equals to n minus 1, no change. We know that minimum I occurs at I by 2, n by 2. In place of I, you substitute n by 2. Then it becomes T of n by 2 plus T of n minus 1 minus n by 2. This is the recurrence in the best case. What is this value? It is same as what is this value? N minus n by 2 is n by 2 minus 1. So that is same as T of n minus 1 plus T of n by 2 plus T of n by 2 minus 1. This is recurrence relation in the best case. Is that clear? Or loosely speaking, what is that we can write? In case of best case, what is that we can write? T of n, can we say that it is less than or equal to 2 times T of n by 2 plus n minus 1? Is this clear? Is that correct? T of n by 2 minus 1, we can say that it is not more than T of n by 2. Hence, T of n by 2 plus T of n by 2, 2 times T of n by 2 plus n minus 1. So this is best case running time reconciliation in case of Quicksort. What is answer to this? What is answer in this case? What is order of growth? Which case of master theorem is applicable? Which case of master theorem is applicable? Which case of master theorem is applicable here?
Second case.
Case 2. By case 2 of master theorem, can we say that to be go of n log n? Even we can even show that if n by 2, if I replace with n by 2 minus 1, we can even show that T of n is greater than or equal to 2 times T of n by 2 minus 1 plus n minus 1. With this again, we can show that I am not going to do that proof. It is big omega of n log n. Is that correct? That means what is the best case running time? Combining these two, what is the best case running time of Quicksort? What is best case running time of Quicksort? Theta of n log n. Is that correct? Is that correct? So therefore, finally, what is best case running time of Quicksort? What is best case running time of Quicksort? Big O of n log n is correct. Big omega of n log n is correct. Theta of n log n is also correct. That means its order of growth in the best case is n log n. Is that clear? What is the reconciliation? T of n is exact, means T of n is equal to T of n by 2 plus T of n by 2 minus 1 plus n minus 1. Or upper bound, if you want to give, T of n is less than or equal to 2 times T of n by 2 plus n minus 1. In place of n minus 1, if somebody writes n, is it wrong? In place of n minus 1, if somebody writes n, is it wrong? In place of n minus 1, if somebody writes it as n, is it wrong? No. This is also correct. No. This n is index comparisons. This is element comparisons. That is the difference. That's why you find n also, n minus 1 also. Some textbooks, what is that? They simply, if they write T of n is less than or equal to 2 times T of n by 2 plus theta of n. This is also correct. Some textbooks, they might write like this: 2 times T of n by 2 plus big O of n. Is this correct? This is also correct. Some textbooks, they might even write like this: 2 times T of n by 2 plus some constant into n. Is that correct? That is also correct. All are correct. They are correct reconciliations for which case? Best case. Is there any doubt in the best case calculation? Is there any doubt? Is there any doubt? Are you following?
Sir, no doubt.
Okay, thank you. Thank you. Now, can you please tell me what is the reconciliation in case of worst case? Equation to substitute I equal to 0 or n minus 1. Will you get answer? What is reconciliation in the worst case? What is reconciliation in the worst case? Equation 2 I equal to 0 or n minus 1 you substitute. I equal 0 equation 2 if you substitute, what is that we get? In equation 2 I equal to 0 if you substitute, what is that we get?
It is in front of us here itself.
That is n minus 1 plus t. This one. This one we get no? Or we can say that it is this. Both are same. So what is the worst case running time of what is Quicksort? What is worst case running time of Quicksort?
Big O of n square.
Big O of n square, theta of n square, big omega of n square, all are correct. Order of growth is n square. After that notation, whichever notation we want, we can use. Best case order of growth is n log n. Worst case it is n square. Now, as I mentioned earlier, Quicksort is a special case where average case running time is same as average case running time is same as usually average case running time is same as worst case running time. But Quicksort is the special case where average case running time is same as best case.
Best case.
Best. That means you tell me what is average case running time of Quicksort? What is average case running time of Quicksort? Same as best case. That means what? N log n. N log n. So finally, order of growth, if we write order of growth, this is n log n. This is n square. This is again n log n. But practically, this algorithm used, okay, no, widely used. Why? Because only in the worst case it is not good, but on average it is very good. No, on average it is very good. N log n only. N log n. Okay, I stop here. If there are any questions,